Today, we are diving into the absolute ultimate backup plan for humanity's survival. For 4.5 billion years, Earth and Mars have just been quiet planetary neighbors. But as we look to the future, Mars is really stepping into the spotlight as our grandest insurance policy. It really brings up the ultimate question we have to ask ourselves. We talk a lot about getting to Mars, right? Building the massive rockets, planting a flag, the whole shebang. But are we truly prepared for the mind-bending biological reality of migrating to another planet? Because as it turns out, moving to Mars doesn't just mean changing our zip code. It means fundamentally changing what it means to be human. So first things first, we need to understand exactly why we're doing this. For over 400,000 years, human survival hasn't just been a stroke of luck. It's been about preparation. We migrated, we built tools, we mastered agriculture. We are instinctively driven to secure a backup plan. Whether we're looking down the barrel of global warming, a catastrophic asteroid impact, or another global pandemic, establishing a multiplanetary society is quite literally our species-level insurance policy. Okay, but if we need a backup plan, why are we so obsessed with Mars? Why not literally anywhere else in our solar system? Well, let's take a look at our options. Mercury and Venus? They are practically furnaces, way too close to the sun and insanely hot. The gas giants like Jupiter, Saturn, Uranus, and Neptune don't even have solid ground to stand on. Now, Saturn's moon, Titan, is a really strong theoretical contender, but it's just impractically far away. So by sheer process of elimination, Mars isn't necessarily the perfect option, but it's for sure the least impossible one. But man, when you actually compare Earth to its cold little sister, the differences are staggering. Mars is only about half the size of Earth, meaning it has roughly 1/3 of our gravity. The atmosphere is incredibly thin and weak. We're talking an atmospheric pressure of a measly 1% compared to what we feel right now. And even though that thin atmosphere is 95% carbon dioxide, which is a greenhouse gas, it's just way too sparse to actually trap any solar heat. Our fascination with this hostile world has evolved so much over time. Back in the late 19th century, people looking through early telescopes actually thought they saw physical canals, which kicked off wild rumors of an intelligent Martian civilization. But in 1964, the Mariner 4 probe sent back data that totally crushed those dreams, showing what looked like a dead planet. In 1976, the Viking landers confirmed a rocky terrain that used to have flowing rivers. But the real game changer, that was in 2008, when the Phoenix lander actually dug up frozen water hidden right beneath the Martian soil. Now, despite finding water, the environment is still incredibly hostile. Because Mars lacks that dense atmosphere to trap the sun's warmth, the temperature swings are absolutely brutal. We are talking plummeting by over 100 degrees Celsius from day to night. But here is the silver lining. Massive amounts of water ice are currently trapped at the Martian North and South poles. If we could somehow melt all of that ice, there is literally enough water there to cover the entire planet in an ocean 22 meters deep. Think about that. Getting to that water, however, is a total logistical nightmare. Traveling to Mars is not like popping over to the moon. Even at its closest, Mars is still 1,500 times farther away from Earth than our moon is. And because of how planetary orbits work, the launch window for a relatively efficient trip only opens up once every 26 months. Section 1. The Survival Protocol. Keeping the first colonists alive. With companies like SpaceX planning manned missions potentially by 2029 or 2030, the very first hurdle is just keeping people alive on severely limited resources. Like we just talked about, there's water on Mars, but it's frozen at the poles, while the most survivable temperatures are near the equator. And since dragging glaciers to the equator is currently impossible, colonists will have to rely on extreme water conservation. Just like they do on the International Space Station, colonists will have to recycle literally everything. Yes, that means capturing, filtering, and drinking every single drop of sweat and urine. Bottoms up. Food is another massive hurdle. You can't just plant potatoes in the Martian dirt like in the movies. The soil, called regolith, completely lacks organic material, and the surface gets constantly blasted by deadly solar and UV radiation. So to eat, colonists will have to build highly specialized weather-controlled greenhouses. They'll be growing plants hydroponically, using nutrient-rich solutions, safely shielded from that harsh environment outside. And speaking of shielding, how exactly do you build a house when you can't exactly pack a rocket full of bricks? Scientists are exploring some incredible solutions here. One idea is using 3D printers that mix Martian regolith with specific additives to literally print habitats right on the surface. Or, even more fascinating, colonists might just move underground into ancient, hollowed-out lava tubes to hide from the relentless cosmic radiation. Section 2. Terraforming Mars. Conquering the planet. Now, living in underground caves isn't exactly a thriving civilization, right? To ever ditch the spacesuits and build a breathing world, we have to terraform the planet. It's a massive, multi-century chain reaction. Step 1, heat the planet up. Step 2, that heat melts the polar ice, releasing water vapor into the thin air. Step 3, that vapor acts as a greenhouse gas, trapping more solar heat, further thickening the atmosphere, and eventually letting liquid water pool on the surface. And finally, step 4, we have to figure out how to shield this newly created atmosphere with a magnetic field. So, how do you heat an entire planet? The proposals are straight out of science fiction. One idea? Capture and purposefully crash roughly 10,000 meteorites right into the Martian surface. The friction of the impacts would generate immense heat, and the meteorites themselves would deliver crucial oxygen and nitrogen. Another proposal, one heavily popularized by Elon Musk, involves deploying giant orbital mirrors in space to essentially laser-focus sunlight directly onto the poles. But here's the catch. Even if we thicken the atmosphere, Mars still lacks the natural magnetic field that Earth has to protect us from deadly cosmic radiation. A highly theoretical yet absolutely mind-blowing solution actually involves one of Mars's own moons, Phobos. Scientists hypothesize that we could essentially break Phobos down, since it's rich in charged particles, and turn it into an orbital ring around Mars. The constant rotation of those charged particles could literally induce an artificial magnetic shield around the entire planet. No way, right? Section 3. The New Human. How the Planet Conquers Us. Okay, let's say we pull this all off. Over thousands of years, we actually build a breathing society. Here is the ultimate surprising payoff. While we conquer the planet will inevitably conquer our biology. It all comes down to a concept we all know. Charles Darwin's survival of the fittest. Environments violently shape biology. As humans begin to live, reproduce, and pass down genes in an environment with 1/3 the gravity and vastly different radiation levels, the human body will be forced to rapidly adapt. The traits best suited for Martian survival will absolutely dominate future generations. The structural mutations over just a few generations will be shocking. Because of the low gravity, your heart won't have to work nearly as hard to pump blood, meaning human hearts will naturally shrink in size. Without strong gravity pulling fluids downward, bodily fluids will shift upward, leading to slightly expanded skulls. And while the first colonists will definitely suffer from bone density loss, future generations will likely evolve much thicker skeletons to biologically compensate. On top of that, due to the intense background radiation, any genes that naturally resist cancer will become highly prevalent and heavily selected for. And then there's the visual transformation. Here on Earth, human skin color is dictated by eumelanin, which is a pigment that acts as a natural biological sunscreen, giving us darker skin tones near the equator where UV radiation is highest. But on Mars, that unique cocktail of cosmic rays and solar radiation could force the human body to evolve an entirely new, highly protective pigment. Scientists predict this new biological sunshield will likely turn future human skin a distinct shade of orange. When you put all of these evolutionary changes together, the smaller hearts, the thicker bones, the expanded skulls, the orange skin, you realize we aren't just creating a human colony. We are witnessing the inevitable birth of an entirely distinct species. Homo sapiens will evolve into true Martians. Which leads us to our final thought. We started this explainer by looking at Mars as our ultimate backup plan, an insurance policy to ensure humanity's survival. But if securing that survival fundamentally alters our DNA, reshaping our bodies and stripping away the very biology that makes us Earthlings, are we truly saving humanity? Or are we just replacing it with something else entirely? Think about that for a second. Thanks so much for tuning in, and we'll see you in the next